Obrigada. Passava então a palavra ao segundo membro deste tema, da cooperação em robótica, que é o Kanna Rajan. Eu recordo que o Ken é investigador principal num instituto de investigação dos Estados Unidos e que tem desenvolvido um interessantíssimo projeto de colaboração justamente com a Universidade do Porto, com o Centro de Investigação da Universidade do Porto, onde trabalha o João de Sousa, que acabámos de ouvir, e espero que ainda tenhamos tempo de ouvir falar um bocadinho desta experiência de colaboração transatlântica. Vamos ver se os oradores nos ajudam a deixar tempo para o debate. Kanna, please, 15 minutes max.
Thanks. So you heard pretty much João set things up for me. I think the basic case here, what we want to make is, based on what João's already talked about, is a case for intelligent robotics to be a central player for blue growth, but particularly for the ocean sciences, for exploration, surveillance, and oceanography. So in this context, I just want to give you a perspective of where I've come from, because it informs you of where I'm hoping to go. And that is that over the last 15 years, I've spent 10 years at NASA, and now 7 years at Embari. I was part of 2 space missions, which is a little unique even within NASA. And the first was in 1999. Deep Space One was the first closed-loop AI system. That is the first intelligent robot in space. And it's still very rare to find these kind of vehicles up in space. 65 million miles from Earth, completely closed loop. And the notion of intelligence is decisions are being made in situ on board, not by human beings on the ground. So that was 1999, and fast forward to 2003, where the Mars Exploration Rovers mission, which was not the mission that we are talking about, which left last year, or this year, but this was in 2003, and the command and control of both the rovers was done by software that my group wrote at the NASA Ames Research Center. And this mission is still ongoing. We don't hear it in the news, but one of the rovers, Opportunity, is still alive, still being controlled by the software that we wrote. So that's sort of the context of where I'm coming from in terms of making intelligent decisions for vehicles in extreme and hostile environments. So the notion of intelligence is to leverage what human beings do very nominally. We perceive the world, and by perception, there are lots of different examples. We look and see and perceive our environment in the context of where we are and what we are doing. So for robotic elements, for instance, vision is very important. So perception is understanding what we are seeing. What am I seeing? Seeing a bunch of people in an auditorium. Then we deliberate. Human beings naturally think about what we are doing. If I'm walking here and I'm going to step off the stage, I'm thinking about what, or my brain is thinking about, at least I hope it is thinking about, what I'll be doing when I step off the stage. And the notion here is that we are planning. The brain is continuously planning, the human brain. And finally, of course, acting. These are robotic elements, physical robots in the real world, so there'll be action. So in this case, you can see a rover from LAC in Toulouse, which is an elite robotics lab here in Europe. And the whole paradigm of sense, plan, act, perception, deliberation, and action, that is the heart of machine intelligence for robots. And so the idea is to be able to leverage these kind of capabilities and to do it in the context so that these robotic elements serve as extensions of the human senses. So we can't be there. We can't be there in Fukushima. We can't be there in the deep ocean. We can't be there in deep space. Machines can, but they need to be smart. They need to be able to make decisions on the fly, in situ, not keep talking to people on Earth or radioing back for home. So that's sort of the gist of what I've been doing, and I don't want to get into the technical aspects of it, but these are some examples. Tracking ocean fronts. The notion here was oceanographic fronts essentially are bodies of water where there are two completely different chunks of water getting together. For biologists, what's important is what's in the middle. There's substantial biota, there's substantial consumption of resources, but what kind of biota, what kinds of biological and chemical activities go on in the interface is phenomenally important. But it's very hard to get a ship and stick around in the middle of the ocean trying to figure out exactly what's going on. It's just not sustainable. Robots can. And we've demonstrated that we can track, sample, and return samples from within a front and outside the front. Sampling is the standard fundamental problem in the ocean sciences. The oceans are highly undersampled. The traditional approach, the Charles Darwin approach, is to take a ship, drill holes, what we call as drilling holes, taking CTD casts, and making an analysis of what we've seen based on that limited sort of sampling capability. With robots, we can have continuous sampling over limited amount of space, but they can be deployed over and over and over again. So the notion that robots have a role to play is now slowly creeping into oceanography, and we are seeing a huge inroad, but it's still stymied by the fact that funding and the capabilities needed to deploy robots is somewhat limited. The question then is, what is a robot? And here's sort of a very eye-candy approach to what Hollywood thinks is a robot. But actually, robots are quite diverse. And you saw certainly the capabilities that João's lab has brought to bear. But there are other kinds of robots, including, of course, those on different planets, certainly in the air, and certainly AUVs and spacecraft that we've seen. But what's also important is the notion of robots in the environment has also had a paradigm shift. We can instrument different parts of the terrestrial planet and certainly different parts of the oceanographic realm to be able to sample with sensor networks, with very robust platforms which can sample and give you a perspective, a situational awareness of what's going on in real time. And we can do it over a large spatial spread, a large area, and we can also do this over a large period of time. So the question is, what's actually happening? And what is actually happening in the real world is, given the last 5 to 10 years, the quiet revolution or the not so quiet revolution that's taking place, these are examples of different robots coming from different labs, which are in the real world, which are actually making an impact, not just in academia, but actually doing a substantial amount of science. The interesting thing about this is they are very low cost. They are very reachable, and they are capable of bringing the kinds of data that we've only imagined for the last 100 years. So this is within our realm. We are doing it now. Different groups are doing it. And what you're seeing is some samples of it, including, if you've been looking at the news, extreme right, the new notion of delivering packages by drones by Amazon. So this appears like as it's science fiction or fantasy, but it isn't. And you've seen the kinds of things that João has shown you. So the question is, what exactly is happening? First, where we are in the field of robotics, it's become extremely eclectic. We're looking at different paradigms, different kinds of robots, and I showed you some examples of it. So the notion of a robot is not a talking anthropomorphic robot, but different kinds of sensor networks. You can make a room into a robot, and there are lots of those intelligent rooms all around.
5 minutes, okay?
Sure. But it's also become, and this is fundamentally important, is it's become egalitarian. So we are now in a realm where robotics is no longer the exclusive right of a few. It has spread enormously. And the two reasons, one has to do with the open source revolution. In software, in hardware. You can download all kinds of complex pieces of software, including the T-Rex system that João was mentioning, which my group developed at Edinburgh, which I'm not going to talk about here, but it's a fundamentally command and control system which you can deploy in situ on any kind of a robot. The second has to do with the size and the shrinking of sensors. And the real reason for that has been fundamentally it's sitting in your pocket. This is really one of the biggest revolutions that has taken place. It's driving a lot of what we are doing in robotics altogether. So to leverage a lot of that stuff, João and I have been collaborating for the last couple of years. This is where we are going to be going. This, what you're seeing, and João touched on it, is to be able to track in space and time tagged molars. And we are hoping to do this in May off the coast of Algarve. So the notion here is we'll tag a bunch of molars with tags built at FIUP in Porto. And to be able to figure out where the tags and the fish are spatially located, you're going to fly autonomous airplanes which have embedded intelligence on board. And once they've identified the actual molars, you're going to dispatch more expensive assets. Surface platforms for communication and getting data, and underwater platforms for getting the three-dimensional view. So imagine if a chunk of the ocean was put under an MRI scan, and you got a 4D view in space and time of what a fish was seeing. That's what we hope to get by this May. So all of this is to try to convince you that we are doing things not just at the cutting edge, but the bleeding edge, and driven by a lot of the technology that has come from very different places, to a large extent here in Portugal. So where are we in terms of making these things happen? I think, personally speaking, that investing in education should be fundamental. You can be in all kinds of austerity measures, whether you're in Southern Europe or not, but if you don't invest, you're basically killing your future. So if there are people here in the Portuguese government, I hope you're listening up. I think lessening bureaucracy is fundamental. You need to have people who are incredibly smart, and I see them a lot in João's lab. These are world-class. I can pick them up, take them to Silicon Valley where I live, and they would be running and making tons of money for themselves. But the idea is that if you don't innovate and innovate here, we can keep talking and having these beautiful meetings, but if there's no action, it's a whole lot of, pardon my French, but it's bullshit. So we really need to get to the point where there's less talk, more action, and we are seeing it here. It's certainly in Porto. I don't know about Lisbon, but certainly in Porto. So we need to, João's already pointed out, to make things happen. This is not simple. It's not the pervasiveness of one single nation, but we have to have international cooperation. Now I'm going to show a similar map to what João's already showed. This is a high point of where we want to be, and we want to be working with people here, and certainly different international partners, is to monitor and to secure the marine protected areas, which look very nice on paper. When they're paper tigers, politicians like it, but there's no way to actually enforce and monitor. We think we have the technology, and it's not just the two of us. There's a whole collection of people, and we think that we need your help and support to make this happen. We don't want your money, but if you have the money, of course, we'll take it. So, last slide, and this is just to say that where we want to go from a robotics perspective, it includes a vast swath of exploration, surveillance, monitoring, but certainly oceanography. Because it's really key that we bring tools for science to understand the larger picture of what is happening to the planet. And I think we can do that with the kinds of things that you've just seen from João's slides. Thanks very much.